Hello everyone, welcome to our pre-calculus pre-recording video. This is our lesson 4, determining the domain and range of the trigonometric functions and fundamental trigonometric identities. Let's look at the agenda. Signs of trigonometric functions in a given quadrant, determining the signs of trigonometric functions in a given quadrant. So like the concept and practice work, then determining the domain and range of the trigonometric function, fundamental identities, and how to use it to find out the exact value. Okay, so let's look at the first one. You already have the concept about this slide actually. uh, the sign of different things, suppose sine, why sine is negative here, why cos is negative here. Do you see the reason? The reason is actually simply due to the relative position, due to the relative position of the point in the given quadrant. Bring the let me bring the annotation toolbar. Okay, so now I think, suppose in this quadrant, as you can see, any value here in this place, you can see the first value is negative and the second value is positive. And from our concept of sine, cosine, and tan, you know that this second value is the sine. That's why in this box sine is positive. Since sine is positive, cosec is also has to be positive. So that's the idea why something is positive here and something is not positive there. The concept is that. So the concept is coming from there. Okay, and then same goes with the tan, same goes with the cos and sec also. Similar, same concept. This is due to the position of the point in the given quadrant. Okay, in this quadrant, you know, any point, suppose any point you write, both x value and y value, both of them will be negative. That means both sine and cosine will be negative. So since sine and cosine is negative, tan will be positive, because tan is the ratio of sine and cosine. Okay, and minus minus is cancelled out, then we will get it positive. But other than that, sine and cosine is definitely still positive. That's why it's still negative here. That's why others are negative written. So the reason, what is the reason? The reason is due to their position in the given quadrant, because that is how we plot the point in that quadrant. We can this concept is more aligned with the unit circle approach. You can think about the unit circle and what will be the point on that unit circle in a given quadrant, then it will start making more sense. So if we want to do some application of the previous concept, suppose this math, in which quadrant this condition lies. Sine theta is negative, so first condition is this. So sine theta is negative where? Sine theta is negative here and here, because here all is positive, here sine is positive. So sine theta is negative in this box, in these two boxes. Tan theta is negative where? In this box or in this box? Tan theta is also negative here. So that means both of them fits only in this quadrant. So it is fourth quadrant. So the answer is fourth quadrant. This is fourth quadrant. This is first, second, third. This is third, and this is fourth quadrant. Okay. So we will have to look at which condition fits. Suppose this 34 number, cosec theta is positive. Where cosec theta is positive? This is greater than 0 means positive. So cosec theta is positive in the second quadrant and in the first quadrant. In the first quadrant, everything is positive. Then cos theta is negative. Where cos theta is negative? Cos theta is negative here and here. So basically both of the condition fits in the second quadrant. So second quadrant is the answer here. Let's do another one. Which one? This one. Suppose this is saying cos theta is positive. So cos theta is positive here and here. And tan theta is negative. Tan theta is less than 0. So tan theta is negative in this box. Tan theta is negative. That means the answer is fourth quadrant. So this is how we can find out the solution. As we said, there is a nice mnemonic here also. All should take candy, all should means sign, tan means take, candy means cos. So we can think it this way also. Okay, just to keep all this value in mind and to do the math quickly, you can just keep it in mind this way. Now this is about the domain and range of the trigonometric functions taken from the book. This page is also in the book, and this all of them. And this is just to build the concept about the domain and range of the trigonometric functions. As you know, the domain are the possible input and range is the output. Domain are the input, range is the output of the function. So suppose y equal to sine theta or y equals to cos theta, whatever it is, something. So what is the input and output here? Input is the value that you put here for the theta. Suppose let's say sine 30 degree. Suppose we put theta equals to 30 degree. Okay, so if we put sine theta equals to 30 degree, then what is the answer? Sine 30 degree equals to what? Sine 30 degree equals to 1 divided by 2. Okay, 1 divided by 2. And then this 30, this is the domain, because this is the input that we put. This is the domain, and this 1 by 2 is the range. This is the range. This is the range. So that means the thing that we put is the domain, and the output, the answer is the range. Suppose if you put sine 30 in the calculator will give you 1 by 2 or half, 0.5. So the answer is the range, input is the domain. Now you can see that the due to the difference in their placement, suppose tan theta equals to sine theta divided by cos theta, cot theta equals to cos theta divided by sine theta. So for all these different reasons, and even if you look at cosec theta is basically 1 divided by sine theta. Sine theta means y here. So again, y now cannot be 0. Sine theta, the value of sine theta should not be 0 here. So you see, due to the different conditions, due to all these conditions, actually all the input it cannot take, and all the output also sometimes it cannot give. All the equations, all the functions, all these 6 trigonometric functions, they do not take all the input. They don't. All of them together do not take all the output. Cannot give the output all of them. The reason is at some certain value they are undefined. Suppose here if y equals to 0, then this function becomes undefined. So this kind of situation. Okay. So suppose this y value, sine theta. So sine what value of theta equals to 0? We will have to think about that. That means sine 0 degree equals to 0. Sine 0, 0, 0. So sine 0 degree equals to 0. That means sine 0 we cannot put here. Here it says that cos sec equals to 1 by cos. 1 by cos means this is x. So basically cos is here. And for what value of cos is 0? So it is 90 degrees. So cos 90 degrees is 0. So that means this function cannot take 90 degrees. Just here. So due to all these conditions, actually we have some restriction. So what type of value we can put and what type of value we get as an output, this is summarized here for different values. Sine theta can take all the real numbers. I mean, input can be anything, and it will keep generating the different answers. Of course, all the answer ranges from -1 to +1 inclusive this way. And cosine also, it goes, it can take anything, and it will give us -1 and +1 inclusive. Tan theta, f theta equals to tan theta, all real numbers it can take, but it cannot take odd integer multiple of pi by 2, because in that cases 90 degree, at 90 degree, 270 degree, that kind of value, we have our let me show you this value and this value. this is 90 degree and 270 degree, we have our cosine theta equals to 0 at 90 and 270. And if cosine theta equals to 0, then that function is undefined when it is tan, because tan equals to sine by cos, this equals to sine by cos, sine by sine theta divided by cos theta. So if cos theta equals to 90 degree, if it is 90 degree, answer is coming 0, and sine theta, whatever it is there, this cannot be, this is 1 actually, so this cannot take it, it becomes undefined. So this is why, due to this limitation, we have some condition, and every time it goes, in trigonometric angles are actually repetitive. It repeats every time it comes here, again it will hit here. Suppose it comes, then again it hit here, then it comes back, again it hit at this bar, then again at this bar. So that you can see after some certain period of time, it will continuously hit this bar and this bar to make it undefined. That's why we get it odd integer multiple of pi by 2, and we can actually show it also. This is 90, this is 270, so that means 90 means 1, you can write here 1 into 90, then odd integer, that means 3 into 90, then the next number will be 5 into 90, odd integer multiple. Odd integer multiple means like this, 1, 3, 5 into 90, then next number will be 7 into 90, and 1 into 90 means this value, first value. I'm just showing one of the things where it is undefined and how it undefined thing comes. Then 3 into 90 means 270, this equals to 270. This means 450. This means 630. 7 into 90. And if you write it in the calculator also, you see your calculator will not give any answer for all this value, 10, 270, 450, and 630. It will say that it is undefined. Or if it is simple calculator, then it will say that math error, because at that time the memory overflows for that calculator. Okay. And same thing goes with the sec theta and cosec theta due to this undefined case, For cot theta also, see, there is a condition for undefined, and for that undefined thing we have this restriction. So basically, some of the values it can take, some of the values it cannot take. So if it can take, the values that it can take are the domain, and if it cannot take something, then that is the restriction. Okay. Output, whatever the output it gives after taking that angle value, that is the range. Just to summarize everything, that's the one line takeaway. And always for this sine, cosine, and tan, always we can check, if necessary, always we can check which values are valid, which values are invalid, which values it can take, which values it cannot take. Okay, always we can check when necessary. And from the graph also you will notice that this is continuous, and this is actually goes forever. This is if you, and we have classes for drawing this graph for sine, cosine, etc. For sine graph and cosine graph to understand the properties. So sine and cosine graph we will draw, because to understand the sinusoidal curve we need to draw it, plot it. So we have classes, separate class for this concept. Okay. But just to show you what happens here, this graph is continuous. This graph, all these graphs goes forever in this direction, and then like this, this, it goes continuously. Okay. Even the tan graph also, this continuation happens. This continuation happens. Just to give you a brief heads up about these graphs. How do we get all these graphs? By putting a different angle here. Suppose sine 0 degree, 30 degree, 45 degree, 60 degree, or even decimal values also you can put. For tan, by putting different tan value, then some answer will start coming, and then by plotting we can get these graphs. Now, fundamental identities. What are the fundamental identities? In trigonometry, we have, this is actually for trigonometry fundamental identities. So we can say that fundamental trigonometric identities. This will be the better word here. There are tons and tons of identity in trigonometry. Sometimes some people say that trigonometry is difficult, and that is because trigonometry has a lot of identities. Okay, tons and tons of formula-like thing in the trigonometry. Suppose cos alpha plus beta equals to this, sin alpha plus beta equals to this and that. Tons and tons of things comes because we can actually modify it a bit, and then it becomes a new thing. Okay, but all that modification happens from these fundamental identities. We will have to maintain these rules everywhere. We cannot go beyond these rules. Okay, that's why it is called fundamental, because other identities comes by using these identities. Okay, this is why it is called fundamental identities or fundamental relationships between these trigonometric ratios. Tan theta equals to sin theta divided by cos theta, and we have seen this in our unit circle approach also, this kind of thing. Cosec theta relationship for cosec theta is 1 divided by sin theta, and this we can also discuss it from the concept of ratios in a right angle triangle, ratios of the sides. From there we can actually understand it. This is sin square theta plus cos square theta equals to 1. This is basically a Pythagorean theorem. Let me show you this thing here. This may suppose in a unit circle, let's say if we draw a triangle here, this is 90, this is some angle theta, radius is 1 because it is a unit circle, then this is cos theta, and this is sin theta. So our Pythagorean theorem says x square plus y square equals to c square, or hypotenuse square. That means cos square plus sin square equal to 1 square. 1 square means 1. That's why cos square plus sin square equal to 1. See, very easy to prove this relationship. Very easy. This is cos, this is sin. Pythagorean theorem says this is square plus this is square equal to this is square. From there we get this. And how we get this? This one how we get? We divide this equation by sin or cos. Then we will get 1, and then we will get 1. So first divide it by cos. So cos square divided by cos square theta. Then this also cos square theta. This also cos square theta. Okay. So see, sin square theta divided by cos square theta means tan square theta. This relationship, this one, we use it here. So sin square theta divided by cos square theta equals to tan square theta. Then cos cancel out. 1 divided by cos square theta equals to sec square theta, which is this relation. This one again here. So 1 divided by cos square theta equals to sec square theta. So that means from this one we can actually develop this one, and similarly we can develop this one. How to develop this one? The rule is we divide everything by this equation we divided by cos. So next equation we divide it by sin. Let me show you that also. So you divide it by sin square theta, then this one sin square theta, then this one sin square theta. When we divide by something in an equation, we will have to divide it everywhere. Okay. So sin cancel out. Cos square theta divided by sin square theta equals to cot square theta. This one and this one. One comes from this one. Okay, this is 1. And then 1 divided by sin square theta. 1 divided by sin square theta equals to cosec square theta. So this is how we can establish this relationship. So this one and this one is actually, we can find out this one. We can find out this first one. First one is, that's why super important. Super important, first one. Now, yeah, we have just one more slide. Here, some values are given. Suppose sin theta equals to 4 by 5, cos theta equals to minus this by this. So 2 values are given, we will have to find out the remaining 4, because there are total 6. There are total 6 trigonometric ratios, 2 values are given, so we'll have to find out the remaining 4. So which one? This one? This one? Let's say, okay, this one. Suppose sin theta equals to given half, then cosec equals to what? Cosec theta is the reciprocal of, cosec theta equals to reciprocal of sin theta, that means it will become 2 by 1, which is 2. Cos theta equals to given this, so sec theta equals to what? So sec theta equal to reciprocal of this value, so it will be 2 by root 3, that means 2 root 3 by 3. So it will become 2 root 3 by 3. How it came? It came from, first of all, it became 2 by root 3. Then to remove this root from here, you multiply both up and down by root 3. Then root 3 here. So it becomes 2 root 3 divided by 3. 2 root 3 divided by 3. So this way we get it. Then how to find out the tan? To find out the tan, we have to divide sine divided by cos. So tan theta equals to sine means 1 by 2, cos means root 3 by 2, and you know this 2 and this 2 will be cancelled out. So basically it will be 1 by root 3. 1 by root 3 means root 3 by 3. Because we multiply root 3 and root 3 in the both sides. How this 2 and 2 cancel out? Because if you write, it becomes 1 by 2, and 2 goes up, root 3 comes down, so this and this cancel out this way. Because there is a rule, if you need more extension, then the rule is, if you see A divided by B equals to C divided by D, then the rule is, it will be next time it will become A divided by B into, here C and D will swap the position. So it will become D will go up, C will come down, because C was up here, D is down. So D will go up, C will come down. Okay, the numerator and denominator will switch their position from the denominator of the first function, original fraction, from the denominator of the original fraction. So they will switch. This is the rule. This rule came from here. Okay. So 2 of them are given. We will have to just find out the remaining 4. Not too hard. And try to solve some maths from here, and we'll discuss maths from here during the class time, and we'll try to solve some maths, of course, as usual. And that's all for today. Thank you all. Thank you very much. Have a wonderful day. See you all in the class. Bye bye.